it's not a it's not a relation on it's not a relation on the power set, right? Because there's no reason that one set has to be a subset of another, right? So it's not, you may not, there are elements, there are subsets which are not comparable, right? There are sets which are not subsets of one another. Those are incomparable elements in the power set. But on the other hand, it is reflexive because any set is a subset of itself. And if you have U and V, and U is related to V, and V is related to U, that means that we have double containment, so we have equality of the sets, right? So this is in fact a anti-symmetric relation, all right? And furthermore, it's also transitive because you know how subset works. U subset of V, V subset of W implies U is a subset of W. That's transitivity here. So this is an example of a relation which is which gives a partial ordering. The reason it's a partial ordering is not all elements in the subset are comparable, right? In contrast, if you think about inequality, less than or equal to, any three real numbers, they can be compared, right? You give me three numbers, there's a way to, you know, one less than or equal to the other. Well, just any two numbers are comparable, right? If you give me two real numbers, either one is less than the other or the other is less than the one, you know? So definition, if R is a partial ordering and X and Y are, then we say X and Y are called comparable with respect to R if and only if either X is related to Y or Y is related to X holds. If X and Y in the domain of R, but they're not comparable, then they're called incomparable. All right. So in the example right before that is really the go-to example of that idea. Now, there's another kind of inequality we talk about, which is also corresponding to a relation. Strict inequality, right? This is what we get by looking at a so-called irreflexive relation. Irreflexive means X related to X is not true for any X. So, it's, you know, not just not reflexive, it's maximally unreflexive, right? Nothing is related to itself. That's how, like, strict less than or strict greater than works, right? And if you have an irreflexive transitive relation, it's called irreflexive partial ordering. And irreflexive total ordering is an irreflexive partial ordering, it's a mouthful, which satisfies the trichotomy. The trichotomy states that for every X and Y in the domain of R, either X is related to Y, Y is related to X, or X is equal to Y. This is how less than works, right? X is less than Y, or Y is less than X, or, other possibility, X is equal to Y, right? Strict inequality satisfies the trichotomy for real numbers. And so that's essentially the whole idea here, is to abstract that pattern for an arbitrary relation, and that's what you'd call a partial ordering, all right? So I wanted to introduce this language. We have a second. Let me look at the next homework. I don't think I found homework problems I liked for this, but let me not commit to that just yet. Mission 7, right? No, okay. I have 2 token homework problems on the stuff I just talked about, but they're in mission 7, so that's a ways off, right? That's like after break, so you'll get back to this. But this is where I actually have a little bit of something to test you on your understanding of what I just talked about for the last 10 minutes, all right? Yeah. And then this stuff down here is much more concrete. You guys are going to like this part. Here we're learning how to abstract, how to do that example we did last time with the 2 things. We added them. We got, you know, multiplication and addition with the equivalence classes 0 and 1. This is doing that, but in more generality. And that particular part of this course you will need in other courses like number theory, perhaps, and also Math 421 especially. This modular arithmetic is one of the main examples in Math 421. So I'm invested in here and making sure I leave you guys with a very solid foundation in that, so that when you get to Dr. Sprano's 421, some of you will, you know, you're like, this part of it's easy at least, right? So you can focus on the harder part. Dr. Sprano has much more to say about like partial and total orderings than I do. That's definitely something he's much more gifted at than me. Anyway, I shut up. Have a good break, guys.